Welcome to all. In this particular video, we will see what is PCB or process control block. In the previous session, we have seen the process states and what you mean by process and everything. But now let us concentrate on PCB. Each process is represented in the operating system by a process control block or PCB, also called as task control block. Okay, a process control block or PCB is a data structure used by computer OS to store all the information about process. It is also known as process descriptor. Okay, so when a process is created or initialized or installed, the OS creates a corresponding process control block. Okay, now you have to remember this. So process, each and every system will be having its own processor and now n number of processes, isn't it? User process or system process, because OS has got its own work. It is not like only it will do user works. No, it has got its own management work, performance work, and error. It has to keep track of errors. It has to keep track of logs. It has to keep track of all the memories, their addresses and data, its addresses, and buffers, and so many concepts are there for OS to handle. Okay, now in between, so whenever you create some process, so it will be creating. Okay, so it will be having its own, the system will be, OS will create its own PCB or control block. So this process control block will be having all the information about that particular process. That is the reason why PCB is also called as process descriptor. Okay, so it will give all the description of that particular process. It may be process ID, creation date, creation time, modification date, and termination if there any, or who is the owner, who is using it, and all the information will be stored in that particular block. Okay, so you can visualize this particular image. So this is the image you have to concentrate. So here there will be a pointer. So that is a block. Actually, it's a block diagram, PCB block diagram. So that is a diagram. So here, there will be some pointers. So there will be some process state. So in the previous video I already explained about the states, whatever the available states which are available. Next there will be process ID. Yeah, in the last video I have shown one screenshot also, what is PID or process ID. Each and every process will be given with its own unique identification number. There is a concept of PC or program counter. There will be registers, memory limits will be there, accounting and list of open files, and ultimately whenever you create some process and whenever you have the process, all this information will be there in the row. Okay, now we will see what exactly these things are. So we will be having some data here. So process state, this specifies the process state, that is nothing but a new, ready, running, waiting, or terminated. So we have one diagram itself. In the previous video I have shown that diagram. If you have any doubt, you can check that particular video again. Okay, now there is a process number. So process number is nothing but PID. Okay, it shows a number of the particular process. So why you require all this number? So if you want to terminate a particular process, you can go for that particular PID. Using that PID you can terminate the process. So in Linux, I already, while explaining that process things, I explained that you can use kill command, KILL command followed by PID, so that you can terminate that particular process. So if, for example, if you are in Linux platform, if your Firefox is not responding or your Firefox has crashed, if that is the case and you are stuck somewhere, then you can directly open the terminal and you can go for the top command, so that you can see whether the Firefox it is PC or program counter. This contains the address of the next instruction that needs to be executed in the process. So work of the PC is to store the next instruction, or it will be pointing, it's a kind of pointer, it will be pointing to the next instruction which is being run or which has to be executed. That is the meaning. Okay, then registers. So while explaining, I said registers are the fastest memory. It is very near to this processor. Okay, so whenever I talk about registers, there are different types of registers. Say it may be for instruction register, IR, or MBR. Okay, memory buffer register, or MDR. So memory data registers, or MAR, memory address registers. So it is like MBR, MDR, MAR, IR. So all these registers will be available. So they are the small part of actually space. It's a small space, and it is the fastest one. Okay, because it is very near to processing unit. Okay, so that is the reason why registers are the fastest memory which you can think of in your computer system or in your hardware devices. Fine. So that is the thing. So this specifies the registers that are used by the process. They maybe include accumulators, index registers, stack pointers, general purpose registers, etc. So there are different type of registers. Ultimately, registers are costly and it can store a limited amount of data, but it is very fast. So for processing purpose and all, you can make use of registers. It is faster than RAM. Okay, so it is very fast. Now it is faster than cache memory also. Okay, now list of open files. So there are the different files that are associated with the process. Okay, whenever you use any process, there may be a requirement of some files for that particular process, so it may be kept open. So ultimately the OS has to handle all those things, and all those information will be there or residing in PCB or process control block. Now CPU registers. See, the registers vary in number and type depending on the computer architecture. Definitely, that is the reason why I said different type of registers may be there. That is obviously based on the architecture of the computer. Okay, they include accumulator, index registers, and so on. So I already explained all these things because they are, see, in that particular paragraph what they have done, they have given each and every registers because those registers are required, but not for the explanation. Right now you cannot see, even though I explain, you will think, oh, what is that index register, where it will be, how it will be. You will be having so many question marks in your brain, isn't it? Your mind will be thinking about that. So but see, stack pointers, stack, you know the concept of stack in data structure, and you would have seen that push pop concepts and all. So obviously it will be available in the register. It will actually consider it. There will be a index register, so to get store the information, index information of everything. So there will be general purpose registers for the general work. Then there can be conditional code information if there any information has to be seen. See, something like flag values. Say while writing the program, you would have seen using that, while checking the flag value only, you will decide whether you have to go or not. Say for example, you have a variable called flag. So if the door is open, you are going to set the flag as 1. If the door has closed, then you are going to set the flag as 0. So ultimately program will check only the flag value. If it is 1, automatically it prints that door is open. If the value is 0, automatically the program will think that, or the program will print that door is closed. So based on that, door is open or door is closed. So obviously it is based on the flag value. It is same like that condition code information. If there are any conditions, or if there are any information which has to be highlighted, so all those things will be taken care by all these things. Okay, now you have to remember like that, only that much. So whenever you go in depth with respect to all those things, you are going to learn each and everything. Fine. Now CPU scheduling information. So whenever I say the scheduling concept, each and everything has to be scheduled, isn't it? It is not like they should not fight with each other. There may be n number of processes running concurrently, isn't it? So whenever you are going with respect to processes, there may be so many process in the system, isn't it? So that is the reason why I put that screenshot from my system in the previous video. I put in one of the slides. Fine. So this information includes process priority, pointers to scheduling queues, and any other scheduling parameters. So based on the scheduling concepts, this will keep track of it. Okay, now next thing is memory management information. It is one of the important thing because memory has to be managed efficiently, otherwise there may be a leak of data or leak of memory, and there may be a concept of fragmentation of memory. So fragmentation is nothing but you will be having a set of data in a particular memory positions, and if you are, say for example, you are trying to delete some folders or files, that means at that point, or that at that spot, you are not using that particular memory for the thing, isn't it? You will be, because pointer will be pointing to the next or some other memory locations from where you are going to keep the data or fresh new data, and this particular deleted concept will be kept as it is, though it is kind of fragmentation concept. If you are using Windows, you can go for settings and you can check the fragmentation concept in the memory, so it will give a better graphical representation of fragmentation or memory fragmentation or disk fragmentation. Fine. That is a separate part of story. So this information may include such information as the value of the base and limit registers, page tables, or the segment tables, depending on the memory system used in the operating system. So page table will be having it will be having its own stack of data. Fine. So separated page tables will be there, depending on the pages, number of pages available for the processing. Next, there will be segment table. So there will be see, ultimately this memory is nothing but some blocks will be there, segments can be considered, sectors will be there. So ultimately you have to think in that way. Fine. So in the hardware wise, if you go and see the actual concept or image of your disk, there will be so many partitions, isn't it? Even in your system also you will be having n number of partitions, isn't it? So whenever I use n number, it is not like 1000 partitions and all. Usually you go for 3 to 4 partitions, isn't it? Drive C, drive D, drive E, drive F, something like that. Fine. So that memories also has to be managed by the OS. That is the meaning. Now accounting information, this information includes the amount of CPU and real time used, time limits, account numbers, job or process numbers, and so on. So ultimately accounting information means almost all the information which is required for that particular process creating, or it may take how much time it takes, what it has to do, and what is the number of it. Next, that process number, job number, or ID number, or account numbers. Account number, it is not about the bank accounts, it is about the process. Okay. So if you have any doubt with respect to this, you can check the previous video of that slide. So it will give you the rough idea of process name will be there, modification date, creation date, and who is using it, who is the owner, what is the permission, and what is the PID and the process ID. Each and every information will be listed in that particular image. You can check that particular thing. Next thing is IO status information. So the information includes the list of IO devices allocated to this particular process, a list of open files, and so on. So that means, sometimes your process may require input output thing. It may require accessing the information from the keyboard, or your process may require mouse, your process may require pen drive access, or your process may require speaker access, isn't it? So based on that IO access and all, that status information has to be stored, whether your process has to wait for the hardware devices or it is available. So because see, when you are running n number of processes in a particular system, there is a possibility that some other process would have taken your keyboard informations or keyboard access. Now then obviously you have to wait, this process has to wait for that keyboard, because that keyboard is being used by some other process, isn't it? So it has to go to some queue, it has to wait for that particular resource. So all these things are actually interrelated. So you can think of that process state. There are 5 states, isn't it? You can think of it. Fine. Waiting state, ready state, termination state, new state, isn't it? So waiting state, all the state informations are available, and you have to ultimately link each and everything before thinking of this particular concept. The next thing is threads. Okay, the process model discussed so far has implied that a process is a program that performs a single thread of execution. Okay, that means if you have process, means there is a execution concept, and it is a single execution. You are not going for the multiple execution using one process. So but if the requirement is like if you want multiple process has to be run, so I will give that example also. Here only it is there. Okay, if a process is running a word processor program, a single thread of instruction is being executed. This single thread of control allows the process to perform only the task at one time. That means if you are using word processors, so for example you are using some application which will take all these the textual data or text editors or something like that. If you are not interested to see about word processor, you can go for a text editor, some notepad or wordpad. You are using it, that means at that time a wordpad process is being taken, isn't it? That process is being created, and that process will be running on the memory, because you are using the wordpad, isn't it? Now in the same example you can think of another thing. See, the user could not simultaneously type the character and run the spell checker within the same process. So if the word actually in MS Word, or that best thing is MS Word itself. So after typing one paragraph, there will be small in the bottom tab, there will be some spell checking concept, isn't it? If the spelling is correct, it will put in a green color, right mark in a green color, otherwise it put into marks in a red color. So obviously both the things are going on simultaneously, isn't it? As soon as you type a word, if there is any spelling mistake, it will come in that underline will come, isn't it? In the red color it will come. So how? both the works are working simultaneously because of threads. So that means if two things or more than one thing has to be executed simultaneously, then you can go for the threading concept. So in Java, in C++, in C sharp and all, you have the separate concept of creating the threads for the multiple execution. So you will get an idea. If two things are happening simultaneously, that means there is a threading concept. You have to remember like that. So in day-to-day life, actually you use, but you don't bother, you just go for the technology, that's it. Oh, if you think that okay, it is very good, so if I make any mistake, spelling mistake, it will show, you feel bad, you feel happy, you feel better. But actually technologically, in terms of codes, then definitely all this threading concept also will be running in the background, and you will never bother about the actual technology used for that. Fine. So that is the concept I can explain. So in depth you will be having in the future about this threading concepts. Okay, no worries. But OS has to take care of that threads also. That is the meaning. Fine. Now see, you can see this image. See, single thread and multi-thread, how it happens. So there will be code, data and files. That is a high level thing. After high level thing, there is a intermediate thing, isn't it? Registers, counters and stack. It is required because some data has to be processed, means you need registers. If there are any n number of lines of code, that definitely you need counter, because next instruction has to be pointed, isn't it? That is a PC, program counter. Now stack, because if the variables are there, if you are changing the informations or if you are manipulating the data which is stored in the variables, then definitely you require stack also. Now if one process is using, or one process is running that particular application, that means you cannot do simultaneously, you cannot do simultaneous work. But if you have multi-threading, can you see, it is a replica of three things, isn't it? Say for code or for data, for files, it is a one thing. Then for each and every thread there will be separate space for registers, stack and counters. Can you see that? That means your application works very fast. There is a performance wise, you are increasing the performance. At the same time, you are giving more burden to processor also. Why? Because their processor will not be idle. You are not going to keep the processor as idle one, isn't it? When you are going for multi-threading, that means simultaneously so many works will be happening. So there is a more burden on processor, isn't it? There is a more burden on OS also. It has to keep track of each and everything, isn't it? Which thread has used which register part, which stack part, which counter part. It has to keep track of each and everything. So burden will be more, but performance wise, your application will perform very well, isn't it? So it may be Gmail or MS Word. If you find out the spell check, or if you see the spelling mistake, you feel happy actually, because right there only you can change it. You don't need to work more on that, or you don't need to think much on that. Right there you go for right clicking and you will check the actual actual spelling of that particular word, and you will change it right there. So that means simultaneously you have done two things, isn't it? You are typing the word as well as there is a spell checking concept. This is a simple example. Actually there are so many examples you can get for the multi-threading concept. Fine. So next thing is processor scheduling. So whenever I say there are n number of processes in a particular system, it has to be scheduled, isn't it? There should not be any starvation, there should not be any fight between the processes for the resources or for the execution. Based on the priority, this particular process will be executed. That is the thing. So there is separate problem solving concepts are there for process scheduling and priority scheduling and all those things. We will see all these things in depth in future slides or future classes. Now the objective of multi-programming is to have some process running at all times so as to maximize CPU utilization. That is what I just explained now. So you are not going to keep the CPU idle, you are not going to keep the processor idle. There will be you will be having so many processes, you will be having so many threads which has to be taken care, which has to be considered for the execution. Okay, that is the thing. The objective of time sharing is to switch the CPU among the processors, so frequently that user can interact with each program while it is running. So that means user, as an end user, he should not get to know that there is a problem, or there is a burden on the CPU, or there is a burden on OS. You should not, the user should not think like that. What is the work of user? He will be keep on using. As a user, if you are using smartphone, whether you will bother about the burden you are giving to your OS or your system? Never. Sometimes if you play high end game, obviously your phone becomes heated up, isn't it? It will become hot. How? Because there will be more power consumption, there will be more burden on the system or processor. It will be working like anything, because it has to take care of your graphics, it has to take care of your movement, it has to take care of your maps, it has to take care of your particular thing. That means it may be a person image, or it may be guns, or if you're shooting, or if you're driving a car, it may be anything. If you're playing a simulation game, it may be anything. On the screen, whatever you do, your processor has to take care of each and everything. So that is the reason why sometimes your phone get heated up. There will be more pressure. That time you may think, okay, something has something is happening. But if small pressure, if it is not getting heated up, then definitely you won't bother at all. You will be keep on working in the background. Facebook will be running in the background, Instagram application will be running, and browser application may be running. Above that, you will be playing some high-end games, like say for example Call of Duty, or some other games, some high-end games actually. So you will never bother about the pressure you give to the processor, and it won't show also. Processor also, it is a efficient one, and it will never show that it has the burden. It will try to work efficiently. Fine, that is the thing. So all this process has to be scheduled. That is the meaning. Now, scheduling queues. Okay, as a process enter the system, they are put into a job queue. Remember, these are the I intentionally made all these points. Instead of going for the entire paragraph, it is better to write the points, so that while writing for the examination, you can learn point by point, and you can write the point, and you will get the marks. That is the actual smallest thing. You can do that. Okay, now the first point is, whenever the process entered the system, so whenever the process started, or whenever the process is coming to the system, it will be put into the job queue. Job queue means there is a separate queue, separate data structure, separate architecture. Actually, in that queue, you are going there, that OS is going to put your process, so that you can wait for the actual execution. Now the next thing is, the process that are residing in a main memory and are ready and waiting to execute are kept in on a list called ready queue. Now whenever it enters, it is put to the job queue. When it is ready for the execution, it is taken from there, and it is being set to ready queue. It is a separate queue. So you think how many work the OS is doing in the background, isn't it? As a user, we will never bother, but OS will be having much burden on these particular things. Okay, the next thing is, the queue is generally stored as a linked list. Why queue is stored as a linked list? Because there should be some connection, isn't it? Based on the connection, there should be connectivity between two things. Otherwise, how to switch between the processors, isn't it? How to switch between the queues, how to see that what is the most priority thing, which process has to be stored, which process has to be executed, isn't it? So for example, you are running Facebook, Instagram, and one browser, and suddenly if you get the call, definitely rest of the things will pause, and rest of the things will be keep on working, but the highest priority will be for the calls. That calling, someone is calling, that pop-up window will come, isn't it? That means based on the priority, at that time calling process will get activated, and it will show on the monitor, on the mobile screen or smartphone screen. Fine. So there is a concept of priority also. Next thing is, ready queue header contains the pointers to the first and final PCB on the list. To understand this particular thing, you have to see this image. Okay, this is a ready queue. So there will be a, queue header will be having two things, head and tail. So head will be pointing to, you can see n number of PCBs. Why you have more PCBs? Because in the first slide only I said, whenever the process is created, whenever you are going to create the process, OS will create its own block for that particular process, PCB. So here so many processes are running actually, and each and every queue header, it will be pointing to a particular processor. So process, not processor, sorry, it is a process. Okay, now header and tail head will be pointing to a particular process, and it is nothing but a queue. See PCB3 in a see, can you see in the third line, PCB3, PCB14, PCB6. So it is a kind of queue. Based on the priority it will run, and if the priority is more, and then you will be having a particular tail pointer also. It ultimately it works like a linked list. Okay, so if you are new to linked list concept, definitely you are going to learn, or if you are going to write the program for linked list as well. Fine. Now the next thing is, when a process is allocated the CPU, it executes for the while and eventually quits, is interrupted or waits for the occurrence of the particular event. That means if the process is allowed to execute completely, then it will it will complete its work and it will terminate. If it has to wait, then it will be kept in a separate queue. Sometimes, say for example, your process requires 10 minutes of execution, but if there any other highly priority other processes which has got high priority, definitely it has to execute, right? So at that time, this particular process, ongoing process, has to wait. Because if the high priority job come into picture, definitely operating system will execute that high priority process, not the currently executing one. So there are so many concepts. When you go for the scheduling concept and the problems, when you start solving the problems, that time you get to know what is the priority, how this particular, there are some scheduling algorithms also. So how processor will schedule the process based on the priority, what is the priority number, and so many things come into picture. Okay, you can think, but as of now you keep these things in your mind. Okay, so this is the example for ready queue. You can see n number of queue header will be there, and n number of process control blocks will be there, and all this header will be and two blocks will be there, head and tail, and it will be pointing to the or keeping, it's a kind of pointer actually. Programmatically, if I want to explain, it is nothing but the pointer will be pointing to a particular thing. Fine. The next thing is, the list of process waiting for a particular IO device is called device queue. Now, as I said, some processes may be requiring hardware devices or input output devices. Maybe one process is requiring a keyboard. Obviously, whenever you go for SMS in your smartphone itself, it is better for you to explain, because everyone may not be having the computer system. So at that time, whenever you open your SMS application, whenever you go for typing the SMS, automatically your keyboard come into picture, isn't it? Automatically it will pop up. Keyboard thing will be automatically pop up whenever you press that type a message. How? Because that particular process requires the input output thing, IO thing, isn't it? Input is nothing but that keyboard. Automatically it is popping up, isn't it? Whenever you go for WhatsApp, if you want to send hi to someone, you will go for that tab, isn't it? Press here. When you click that, automatically your virtual keyboard come into picture. That means some of the process may be requiring this particular IO concept. If you think in computer system, you require keyboard and mouse. So if it is not available, if some other process is using that particular IO, then it has to kept in device queue. Fine. So that is called the device queue thing. Okay, next, a common representation of process scheduling is a queuing diagram. Okay, so whenever you want to represent this particular process scheduling, you have to go for queuing diagram. So you can see the queuing diagram below. So there is a ready queue, IO queue, and if there any IO request, so CPU will be having the connection to IO request, time slice, and fork of a child. Fork is nothing but whenever you create a particular request or process, programmatically it is nothing but a fork. So there are some programs actually. We can see what about your lab. If you're having that OS lab, definitely we will be creating fork using C program or C++ based on the question. Okay, we can create it. Fork can be created. Okay. Next, wait for an interrupt. So if there an interrupt or child executes, how it has to handle, and what are the input output thing, and how it has to schedule, what is the ready queue. So whenever I said after the job queue, when the process is ready and ready to execute, definitely it will come and sit in ready queue. So based on these things, queuing diagram only, based on this particular process or overall idea of this thing, process or CPU will take the appropriate decision for the execution. That is the meaning. Fine. So the next thing is, a new process is initially put in a ready queue. It waits in a ready queue until it is selected for the execution. Who is going to select it for the execution? It will check whether all the information has fit or not. If everything is set, if everything is fine, then only that particular process is taken for the execution. Once the process is assigned to the CPU and it is executing, some of the several event can occur. What are the events? There are 3 events. You can see there. The process could issue an IO request and can be placed in IO queue, because if process may require IO at that time, it will be kept in IO queue. The process could create a new sub-process and wait for its termination. There is a possibility. Once process is running, it can create some other process also, sub-process, and it can wait for the termination. That also a one scenario. Okay. The next thing is, a process could be removed forcibly from the CPU and as a result of an interrupt and be put back in the ready queue. So there are some examples where the ongoing processes are terminated and kept in a ready queue. If some important thing comes into picture, or some calls are coming, or high priority process are coming into picture, the ongoing thing can be interrupted. That can be kept in a ready queue. Once the priority job is finished, then you are coming back to the older process. That is the meaning. Okay. So next thing is, okay, CPU scheduler. I don't think I will explain this in the next video, but as of now you think this much. So there can be 3 events. These are the 3 main events. So here I can give an example for that, the last point, removed forcibly from the CPU. So for example, say you are using your browser in your system. Say for example, you are going to plug your USB drive or pen drive to the system. What happens? Your process will be ongoing. Above that, you are going to see one pop-up saying that a new device being plugged. You can, if you want to open the files and folders, or if you want to remove, or if you want to close that window, that one small window will pop up, isn't it? That means USB has got more priority. In that example I'm saying, it is not like actually, but in that example, because you are working on that, isn't it? You are browsing something on Firefox or Chrome. At that time, if you plug something on something to the system, definitely there will be pop-up. That means you can imagine the priority concept. So all these things will come into picture when you solve the problem. At that time, you will get a better picture. Okay. As of now, think this much. Keep all these things in your mind. Okay. Let me wind up here. So thanks for watching. Okay. Rest of the things we will see in the next video.